All right, hello grade 11s. So we are picking up from basically the theorem that follows the one that we did yesterday. I'm sure you might have noticed me that I am not, as I go along, I'm not talking about, but this is theorem 1, this is theorem 2. I'm not so much concerned about the theorem numbers, because nowhere in your test or in your exams will they ask you about the number, the theorem number. What they do want you to understand is the theorem statement. What does the theorem statement say? And if you are looking at a particular diagram, which theorem statement applies in that particular problem? So that's what you are most concerned about as a grade 11 learner. You are concerned about the theorem statement. Each theorem statement, you need to know it fully, what it says, and then how it is applied. All right, because sometimes in your grade 11 your question papers, what they do tend to do sometimes is they will actually say fill in the missing word for a particular theorem. So if you know that theorem well, then of course you'll be able to fill in the missing word. If you know what the theorem statement says, then you'll be able to fill in the missing words where appropriate. So I hope you guys more than want to know what is the theorem number and all of those things, be more concerned about the statement, what it says, and what the diagram says in relation to it. Oh, Gladys. Yeah, I don't have an answer to that question, so I really don't. I really don't. I really don't. Especially now, since I'm back at school, it tends to be very tricky. It's kind of tricky, you know. Yeah, because when I'm back at school, I'm literally, obviously, most of the time at school, and then I come back late at home, and then obviously it's just, I probably can do only one session in the evening because I have other obligations and responsibilities that relate to me as a person. So unfortunately, I can't answer that question, and I can't commit unless Gladys, you guys are willing to wake up very early in the morning. You know, I'm happy to do maybe a 5 a.m. in the morning, you know. No, Gladys, no. This session at 9 o'clock is fitting for the grade 11th. I'm not going to change that one. Unless, like I said, you are willing to wake up very early with me in the morning, Gladys, with your grade 12 counterparts, we can have a 5 a.m. session. You know, after all, it is the grade 12s that need to be in that mode of, you know, early bird catches the worm. All right, so I hope maybe you guys, you don't want to wake up. I get Gladys. I'll see you tomorrow at 5 a.m. All right, what do you want me to do in well, actually, I'm happy to actually start we'll start term 2 topic, but not Euclidean geometry for grade 12. I can do that later on. Let's start with calculus, so I can jump on, we can do that. Okay, no problem. All right, let's get started with the grade 12s, grade 11s, because I can see they are getting impatient. Let's continue with grade 11. Go Scholar. All right, guys, today we are going to do cyclic quadrilaterals. We're gonna do what? Cyclic quadrilaterals. You guys know what quadrilaterals are, right? Yeah. I'm sure you know what quadrilaterals are, because in grade 8 and 9 you were exposed to what a quadrilateral is. A quadrilateral is a four-sided shape, and I'm sure you guys can give me examples of quadrilaterals that you know. Let's see in the comment section if you guys can flood me with the answers as to the quadrilaterals that you know, that you learned in earlier grades. Quadrilateral is a four-sided shape. Can you guys give me examples of quadrilaterals that you know? As I wait patiently for people to comment on the quadrilaterals that they know. Waiting. TK, rhombus, Gladys, parallelogram. Thank you. I'm glad you guys chose two separate and distinct quadrilaterals. I want more. Okay, so rhombus, square, rectangle. Okay, Gusgon added a rectangle and a square. Then Presh added a kite. There's one more that I'm hoping that you guys can give me, the last one. We've got a rhombus, we've got a parallelogram, we've got a square, we've got a rectangle, we've got a kite. I'm missing one last one. Thank you, Blessing. Bless you, Blessing. Blessing. Thank you so much. Trapezium. It's like trap music, right? Trapezium is like trap music. No, I'm just kidding. Trapezium. Okay. So now we are going to do cyclic quadrilateral. What is a cyclic quadrilateral? Now, a cyclic quadrilateral is simply this. A quadrilateral whose vertices lie on the circumference of a circle. A quadrilateral whose vertices, this word vertices, okay, it comes from the singular word vertex. What is a vertex? A vertex is simply, you know, where two lines meet, the point where two lines meet, we call that a vertex. This here is called a vertex. Where two lines meet exactly, we call that a vertex. A vertex will usually form an angle. That's what's key about a vertex. So one vertex, many vertices. Vertex is singular. Okay? A vertex means one. But when you say vertices, it means many, all right? That's plural in English. So you guys, I'm giving you a bit of an English lesson here. So a quadrilateral whose vertices lie on the circumference of a circle is referred to what? Is a cyclic quadrilateral. So if ever you are asked the question, what is a cyclic quad? You did just need to know that any quadrilateral that has its vertices, okay, lying on the circumference, it means the vertices touch the circumference of the circle, then we know that that is a what? That is a cyclic, to refer to that circle, the circumference of the circle, and then the quadrilateral, which is that four-sided shape that is within the circle. So that was what a cyclic quad is, guys. All right. I don't know if people have any questions about that. So if I give you just a diagram so that you can see a diagrammatic example. You see this? You see this? Let's just name it L, M, N, O. So these are the vertices. One vertex, then other vertex, the other vertex, the other vertex. And all four of your vertices. What do you see about all four of these vertices? They all basically what? They lie where? on the circumference of the circle. All four must lie on the circumference of the circle. It is not a cyclic quad when one of those vertices does not lie on the circumference. It is only a cyclic quad if all four of those vertices lie on the circumference of the circle. Okay, I hope we are together there. And I don't want people to have any mishaps or confusions about this particular theorem. Not theorem, but specifically about the definition of a cyclic quad. Okay. Yeah. So here's something that now you need to note. We usually say that this quadrilateral, there's another word that they tend to use. They use this word concyclic. Okay, concyclic is simply just another way, basically, of saying this is a cyclic quadrilateral. Concyclic refers to the fact that all 4 points or all 4 of the vertices, they lie on the circumference of the circle. So they tend sometimes to use the word concyclic. So don't be like, don't be wowed as if you're concyclic. What does that mean? Guys, concyclic simply means all 4 of your vertices, they basically lie on the circumference of the circle. So this word concyclic is just another way of saying cyclic quad. Okay, yeah. So all 4 points, the minute they lie on the circumference of the circle, we say that's a cyclic quad. So alternatively, they use this word concyclic. The minute they say concyclic, you know, I suka, it's a cyclic quad, that one. You know, no questions about it. Okay, right? I don't know if so far there's anything that anyone is like, I don't know, please guys do let me know in the comment section if there be anything that you guys may not grasp about what I've said. But if not, then I'm very happy to continue. All right, and I just want to repeat once again, even for those that are joining, we just defined what a quadrilateral is, and we said a cyclic quadrilateral, what it is. It's a quadrilateral whose vertices, we explained what a vertice is. Okay, vertices is plural for vertex. What is a vertex? A vertex is simply where 2 line segments, they join. Where 2 line segments join, we refer to that point where you can see there, we refer to that as a vertex. One vertex, then we say, when there are many of them, we say they are vertices. So a cyclic quadrilateral is simply a quadrilateral whose vertices lie on the circumference of a circle. We say that is a cyclic quadrilateral. And then this is a diagrammatic representation of what we mean by a cyclic quadrilateral. What can you see here? All 4 of the vertices, they lie on the circumference of the circle. And then we can say alternatively, this here is concyclic. In as much as we can say this is a cyclic quadrilateral, and our understanding is that all 4 of our vertices lie on the circumference of the circle, there's another word that is used in mathematics that says concyclic, and concyclic is simply basically meaning cyclic quadrilateral. All right, so I hope you guys are good with that. I am not actually going to focus on proving the theorems, not yet. I'm not going to do that in the sessions that we are having. My focus now is actually to move from the understanding. Then we are going to go now to the theorem, because I've just defined what a cyclic quadrilateral is. Remember, we need to first understand the concept of a cyclic quadrilateral. So I've defined that. Now we are going to go to the theorem itself. What does the theorem statement say? But I will not prove the theorem. Why? Because I am not in the business at the moment of proving any of the theorems. I will, though, do that when I am concluding Euclidean geometry at the end, so that's how I go about it. Please, you can go ahead and read up on the theorem. You can go and check it out and see how it has been proven, and that's beautiful. Please do that. But for me, in my live sessions, unfortunately, you're not going to hear me prove the theorems as of yet. So here's the theorem statement. If the opposite, okay, if the opposite angles, sorry, wait, what am I saying here? See, now I'm jumping into the converse, not the theorem. All right, because this is the opposite statement that we'd say. So let's cap this for now. All right, I'm gonna come back to it. I'm just gonna leave some space for that, but I just want to return back to the theorem statement itself. The opposite angles of a cyclic quadrilateral. What about them? The opposite angles of a cyclic quadrilateral. The opposite angles of a cyclic quadrilateral are supplementary. The opposite angles of a cyclic quadrilateral are supplementary. What does supplementary mean? From earlier grades, you know that supplementary means add up to 180 degrees. That's what it simply means. So that's a beautiful, real gift. Thank you so much for actually saying that in the comment section. So the theorem says the opposite angles of a what? Of a cyclic quadrilateral are what? Are supplementary. And that's just the theorem statement. Done, finished. Nothing more, nothing less. The opposite angles of a cyclic quadrilateral are what? Are supplementary. So let's just see a diagram here. So when you have a cyclic quad, what is this theorem saying? This theorem is saying if you have A, B, C, D, we can conclude the following. Which angles are opposite each other? So angle B is opposite angle D. So we can say angle B plus angle D is equal to 180 degrees. Then the reason we use is op angles cyclic quad. Op angles cyclic quad. Op angles cyclic. Opposite angles, op angles of cyclic quad. I think that's the accepted reason. Op angles of cyclic quad. So if you go to your theorem statement and your acceptable reason, this is the reason that they have. It's op angles of cyclic quad. Simply put, to the point, we can say that. We can also say angle A plus angle C is equal to 180 degrees. The reason? Op angles of cyclic quad. Okay, sounds straightforward enough, guys. So the new statement that we've learned today is that the opposite angles of a cyclic quadrilateral are supplementary. They add up to 180 degrees. Now, people remember that, I'm sure you know that for all your quadrilaterals that you learned about in grade 8 and 9 and 10, a quadrilateral on its own had opposite angles that were equal. But all of a sudden, when we are looking at a quadrilateral inside of a circle with all 4 vertices touching the circumference of the circle, we are now saying that the opposite angles are what? Are supplementary. All right. So there is something that basically happens to our quadrilateral the minute it has all of its vertices touching the circumference of the circle. The opposite angles exhibit, or they showcase, a supplementary relationship. Angle B and D are 180 degrees. Angle A and C add up to 180 degrees. And our reason, the acceptable reason that we use every time we have to use this particular theorem to actually summate the opposite angles to 180 degrees is opposite op angles of cyclic quad. All right. Then this theorem has what we refer to as the converse of the theorem. Okay. And I just want to say as well from the get-go that the converse of this theorem is simply the reverse of what the theorem statement says. It says if the opposite angles of a quadrilateral are supplementary, then what? Then the quadrilateral, what about the quadrilateral? Then the quadrilateral is not just a quadrilateral, but is a cyclic quadrilateral. Will you look at that? Okay. And then I repeat, this is the converse of the theorem that we just did. If the opposite angles of a what? Of a quadrilateral. So this time around, they are just talking about a quadrilateral. Okay. So if the opposite angles of a quadrilateral are supplementary, then the quadrilateral that you are talking about is a cyclic one. It's a cyclic quadrilateral. So this is a situation where you are given just a random quadrilateral, and it just so happens that you actually find the following, that is 130, let's say for instance, and that is 150. This is A, this is B, this is C, this is D. This is a quadrilateral. It's standing alone. There's no circle. All right. But what you find is that angle A and angle C are opposite each other. All right. Look at the statement. If the opposite angles of a quadrilateral, this is a what? It is a quadrilateral. Okay. And its opposite angles, what do they do? We can see that angle A plus angle C is 30 plus 150, which gives you 180 degrees. We can see that from the diagram. From that, we can then conclude, therefore, A, B, C, D is a cyclic quadrilateral. Okay, why do we say it's a cyclic quadrilateral? The reason that we give there is op what? Op angles be very careful. We need to be very careful with this one. We say op angles supplementary. Okay, op angles supplementary. Op angles supplementary. Okay, so I look at the statement again. If the opposite angles of a quadrilateral, so this is just a quadrilateral, you are given this quadrilateral, it's given to you. If those opposite angles are supplementary, then the quadrilateral is a cyclic quad. So in short, whenever you are asked to prove that something is prove that a quad is cyclic quad, you have to look at this particular theorem and check do I see in that particular quadrilateral opposite angles that are supplementary? If I do, then it means those angles that are opposite each other added together, they give you 180. Therefore, it means that this is not just a quadrilateral, but in actual fact, cyclic quad. All right? No, cyclic quad. All right? And that's very important. The converse is used as a way of proving that a quadrilateral is cyclic. All right, so guys, those are basically the theorem. If you remember the theorem, the theorem for cyclic quadrilateral, the opposite angles of a cyclic quadrilateral are supplementary. That is the theorem. Meaning supplementary means they add up to 180. And if you are given a cyclic quad, your opposite angles, angle A plus angle C is 180 degrees. Angle B plus angle D is also 180 degrees. Opposite angles of cyclic quad. That is the reason. The converse or the reverse of that theorem says, if the opposite angles of a particular quadrilateral, now we are talking about a particular quadrilateral, if they are supplementary, those opposite angles, then we can conclude that that quadrilateral is a cyclic quadrilateral. That's how we prove that a quadrilateral is cyclic quad. So I had given you this quadrilateral. The angle here was 30 and this one was 150. There's no circle around this one. And then you can see, oh, these opposite angles, they give me what? When I add them, 180. So I can conclude, therefore, that ABCD is not just a quadrilateral, but it is a cyclic quad. And my reasoning, op angles supplementary. Simply put, that's how I prove that a quadrilateral is a cyclic quad. All right. Okay, I hope you guys at least you get that very important theorem. We need to know it for ourselves so that we can make sure that nothing escapes our understanding of these two theorems. So I hope if you have any questions, guys, you can ask those particular questions if there's anything. I will embrace the questions if there are any, especially with regards to the statements that have been made pertaining to these theorems that I've just discussed right now for us. Like I said, I'm not going to be proving the theorems yet. I'll do that when we have completed each particular theorem and have at least understood its meaning, what the theorem statement says, and how it applies to the diagram, and we've done problems. Both problems, obviously, that are basic and simple to get us started, and then later on when we start doing exam type problems, and then after that when we are feeling very confident that we've done numerical based problems, the riders, we've done variable type problems, we've done proof type problems, and then we are sure and confident now that exam type questions are things that are easy for us to do, then ultimately I'll go back and then we can review and check the theorems and then see how we prove each individual theorem. That's how I tend to do it. And we are not going to even focus on proving every single theorem. We are going to focus on the examinable theorems, because there are only 5 theorems that are examinable, that we can be examined on, we can be tested on. Those are the ones that will demand my attention and priority, and that's what I will really focus on. And then the rest, you can deal with it with your teacher at school as you see fit, you know. But I will have accomplished and finished my side of the deal, at least for what it's worth. Okay. All right. Let's move on to the next cyclic quad related theorem. This one has to do with a cyclic quad, but very special in the sense that it speaks about A, B, C, D, C1. All right. So what does this theorem say? This one. All right. I know people have been busy with self-studying. Can someone in the comment section let me know what this theorem says? It also has to do with quadrilaterals, but specifically, oh, there we go, real gift. The real gift has landed there in the comment section, and you can see already stating. Okay. So, in essence, the full statement of the theorem says the exterior angle the exterior angle of a cyclic quadrilateral, the exterior angle of a cyclic quadrilateral is equal to the interior opposite angle. The exterior, the word exterior means outside, external. So the exterior that they are talking about is angle C1. Take note, that angle needs to be formed in line with the side of the quadrilateral. So if you see DC, the extension of DC, maybe let's say to E, this line must be aligned with the side of the quadrilateral. That's what qualifies this as the exterior angle we are talking about. Because if that line is at an angle, then that's not the exterior angle we are talking about. We are always talking about the exterior angle that is in line with the side of the quadrilateral. So then we can say comfortably angle C1, which is the exterior, will be equal to which angle? Let me see in the comment section if people understand what we mean by exterior angle and the interior opposite angle. What is the interior opposite angle? The inside opposite angle. Which one is it? Poopy farts. My goodness, what a name. Poopy farts. Wow. Some people are very creative in naming themselves here in this platform. Angle C1 is equal to angle A. You guys are 100% spot on. Thank you so much. It's not angle B. Please don't fall into some crazy trap of thinking it's B. It's not angle D. In this situation, it's angle C1. Let me do something more. Let's say there was this angle. It was angle A2. Angle A2, is it an exterior angle? Yes. Why? Because angle A2 is formed having been in line with the side of the quadrilateral. DA, its extension, is the one that helps form the angle A2. So my question to you then, angle A2, it's the exterior. What is it equal to? Which angle? Modiba is saying C. What do other people, the masses, say? Modiba is saying C1. Okay, Modiba initially said C, now he's changing or saying C1. Likona 600 saying C. Twaro says C. Gladys, our grade 12 enthusiast, is saying C. Cupcake is saying C1. Modiba is saying C2. I don't know where C2 comes from. Remember, people, if it's not in the diagram, then you can't say that at all. Gift is saying angle BCD. Wow. Now that's amazing. Okay. Or you can say DCB. The focus is on C. Okay, so I like what we are doing here. Remember, if you say angle C, you know, the assumption, because you have C1 here, would be that you are talking about the entire angle. Do you know what I mean? But if you are saying angle specifying BCD, then you are talking. Or if you say angle DCB, middle letter, then you are fine. You are 100% correct. So angle A2, which is the exterior angle, is equal to the interior opposite angle. Which one is it? It's angle BCD. Or you can say angle DCB. Okay, this is very important because C, you can't just generalize and say C when there's C1. Remember, angle C could obviously be the entire 180-degree angle if you are talking about angle C. So that's why we specify. We use the conventional, you know, sort of like naming approach, you know, so that we can make sure that we choose the most correct and specific angle. So it's angle BCD. All right, nice. Now I'm going to extend it further. Let's say we had angle D. Let's call it D2. Angle D2. First question, is angle D2 the specific exterior angle we are referring to when we are talking about the exterior angle of a cyclic quad? Is D2 an exterior in the definition of what we mean when we say the exterior angle of a cyclic quad? Okay, Cupcake, Modiba, Gladys, TK, you are confusing yourself. You are confusing yourself. And as a result, TK, because you are being confused by the fact that I am extending all the sides, that is what basically makes a lot of people simply not be able to even solve riders where there's many lines. You are failing to focus on what is there. And this thing, TK, of you not being able to focus when there's many things, that's what is going to actually throw you off. You know, what you are saying is actually reminding me of something else. It's the same thing where you have someone who has resolved, you know, like when you were alone at home, you made this resolve that I'm going to go back at school, term 2, I'm going to kill it. Maybe you saw your results term 1 and you were like unhappy. You were like, Ish, I don't like how things have panned out. I want to improve. I know that I want to apply with a report that is very sweet come end of the year. Then what happens is that you are so focused, you are alone, you know what you want. The minute you arrive at school, you meet your old friends, you guys have your good old times, you start laughing, you start joking in class, you know, you forget about all those resolves that you had made. Why? Because you are being distracted. You get distracted in the midst of everybody else. But what is needed from learners nowadays is people that can actually thrive in the midst of distraction. Yeah, you have to have such an emotional intelligence and emotional maturity as a learner nowadays to be able to thrive and still do well academically despite all of the distractions in and around. So this is kind of the same thing here. You need to focus. You need to zone in to that specific thing that I'm referring to, despite the fact that you are seeing many other lines. You see? So I'm specifically talking about D2. Now, if you are going to distract yourself with all the other lines that you are seeing here, then you're gonna have problems. And as a result, you are going to miss the point. Okay? So please, guys, I mean, like I said, I'm just using an example of life to try and emphasize the point here in geometry. Please, good people, if you want focus, you need to learn how to focus. You are going to have to learn how to focus even in university, despite the fact that you'll be far away of home when you're there after grade 12. You're going to have to learn how to focus and thrive in that space, despite not having mommy and daddy to tell you what you should be doing and what you should not be doing. Some of you will not be able to survive on your own because you always need, you know. So please, I ask you, in the sincerity of my heart, learn to focus. So now, back here, I'm asking about angle D2. You focusing on C1 and everything else is not going to help you. So angle D2, I asked, is this the exterior angle we are talking about when we are relating things to this theorem of exterior angle of a cyclic quad? Remember, I told you, I said that the angle that is exterior must be in line with the side of the quadrilateral. we saw that angle C1 was a formation of an angle, but this extended line is in line with the side of the triangle. This is the exterior angle. That's fine. What is it equal to angle C1? It's equal to, we spoke about the fact that it's equal to this specific angle. At the time, there was no A2, so we said angle A. All right, but we'd have to specify and say angle DAB. That's the angle that's interior opposite. We extended this side. It is in line with the side of the quadrilateral, and we said A2. Is that the exterior angle we are talking about? Yes, it is. So this angle A2 is equal to this angle, angle BCD. Then I ask now this one, is this the exterior angle we are talking about, angle D2? This angle D2, is it an exterior? And of course, according to the definition of what an exterior angle of a cyclic quad is, you guys said no. And hopefully everybody can see that it is no. Why? Because this external or this extended line, it's not in line with the side of the quadrilateral. Therefore, we dismiss this one. We can't say angle D2 is equal to this angle B. No ways, Jose. We can't. Okay. Then what is our acceptable reason that we use whenever we are using exterior angle of cyclic quad? Right. The acceptable reason is simply we write ext angle of cyclic quad. Okay, ext angle of cyclic quad. Right, that's why exterior angle of cyclic quad. Okay. Yeah, that's how we do, guys. That's how we do. That's how we roll. What grade is this? This is grade 11. Okay, so that basically covers the concept of cyclic quad, which I basically wanted to touch on today. So I'm going to give you some work. Okay, let's look at some examples that basically we can do to apply this particular theorem. I hope you guys have seen both. Okay. Oh, the converse. I forgot about the converse. If the exterior angle of a quadrilateral is equal to the interior opposite angle, then the quadrilateral is a cyclic quad. This here, the converse, this is the converse of the theorem that we've just done. The converse says, it starts at 9. If the exterior angle of a quadrilateral, okay, so this is just a quadrilateral. If the exterior angle of that quadrilateral is equal to the interior opposite angle, then that quadrilateral is not just a quadrilateral, but it is a cyclic quadrilateral. It's a cyclic quadrilateral. So practically speaking, this is a way, the converse here is always used to prove that a quadrilateral is a cyclic quad. But what do we have to discover? We have to discover this, that a particular exterior so let's say angle D1, if we can prove somehow, okay, if we find that D1, okay, let's just say D1 was 30 and let's say B was 30, okay, D1 is equal to B, angle D1 is equal to angle B, which is equal to 30 degrees. Okay, this exterior angle which is in line with the side of the quadrilateral, is equal to this interior opposite angle. And the relationship that exists there is the exterior with its interior opposite angle. We know that that is the case. We can then conclude that ABCD is a cyclic quad. What is the reason? Simply this: converse of x angle of cyclic quad. Converse of exterior angle of cyclic quad. We use this particular theorem to prove that a certain quadrilateral is not just a quad, but it is a cyclic quad. So once again, I'm using my dotted lines to just sort of like emphasize that you can see that if this is the exterior and it's equal to this interior opposite angle for the quadrilateral, the theorem says if the exterior angle of a quadrilateral is equal to the interior opposite angle, then the quadrilateral is a cyclic quadrilateral. And our reason is simply converse of exterior angle of cyclic quad, for actually having seen that the exterior D1 for the quadrilateral is equal to the interior opposite angle, which is 30 degrees. That's why we say ABCD is a cyclic quad. Okay, hopefully we are together here. All right, this is the converse of the theorem that says the exterior angle of a cyclic quad is equal to the interior opposite angle. If the exterior angle of a quadrilateral is equal to the interior opposite angle, we say that that quadrilateral is a cyclic quad. And there's the acceptable reason: converse of exterior angle of cyclic quad. Okay, let's look at some example one. Let's look at some problems there where we have to find unknown with reasons. Here is a circle. Here, yes, indeed you do. And I love the fact that you are using the appropriate terminology that is used in this platform. Okay, but we're gonna first look at some examples together, and then I'll give you the game challenges to do. I think I'll give you some time to do those actually in the platform today, if feasible. Here it is, guys. Here we are. X, Y, 80 degrees, 70. We've got D, E, F, and G. Find X and Y, give reasons. Let's see. Anyone want to help us out there? What's the value of X? What's the value of Y? We can start somewhere, and then we can obviously give the reason. We state something, we give the reason. We state something, we give the reason. So what are we thinking? We've learned the theorems relating to quadrilaterals. This obviously is a cyclic quad because all four of my vertices lie on the circumference of the circle. All I want now is X and Y. This is grade 11. Grade 12s as well. Obviously, you know that your grade 11 content needs to be on point so that you can be full on ready to write. My May and June people, I hope we are ready to write. We are preparing nicely. So what's the value of X? X is opposite 70 degrees. So we say X is equal to 70 degrees. What's the reason? Op angles of cyclic quad. Done. X is equal to 70. Update the diagram. What about Y? Y, angle G is opposite angle E. So Y is equal to 80 degrees. Reason? Op angles of cyclic quad. I was waiting for someone to basically say, "Hi, Botishala, what is this? What are you doing?" I was waiting for someone to say that. Okay, Gladys, very good. Very good. I love what Gladys is saying there in the comment section. Okay, I love what Gladys is saying in the comment section. Remember, guys, this is a cyclic quad. Okay, this is nonsense. What I've written here is absolute rubbish. But you see, the thing is, what would lead someone to say this? It would be just that idea from earlier grades. Because remember, when you are dealing with maybe, let's say, a parallelogram, a parallelogram, which is a quadrilateral, you knew that the relationship was that opposite angles were what? They were equal. But now we have a cyclic quad and a cyclic quadrilateral. Let's just go back here, all right? Because you see this here, it was all in the name of just making sure that we are in the same page. The theorem, what is it saying? It's saying the opposite angles of a cyclic quadrilateral are what? Are supplementary. Meaning in what? In other words, they add up to 180. So now when you come back here, you see that indeed this is absolute rubbish. What this guy was writing? Nonsense. Who is this guy? Why is he trying to mislead us? Right? Okay. So as true students that know our theorems, what do we then really truly say? We look at x, we look at the 70 degrees, which is opposite the x. What do we know about the two angles? They add up to 180. Okay, so that means if f is 70 degrees, what is the value of x? Okay. Yeah. Well, I'm glad, because you see, yeah, if you were taught by me at school, you would see me do this a lot. I do this a lot with my learners. I teach them something and they see that it's true. Then the minute I do problems, I do something that's completely off. And that's where I see if learners are really listening to me or they not. You know, that's where I really pick it up. And a lot of the times, it's a few of them, because most of them, they just go with the flow. They just so reliant on what I say, and they don't really pay attention to the truth of what I say and what is false that I say. So I'm happy that you were questioning your entire experience, because it's in that discomfort that you then need to find the truth. So anyways, in this situation, x is equal to what? 110. I know some of you will say x plus 70 is equal to 180, which is fine. I don't mind that. X plus 70 degrees is equal to 180 degrees. Okay, x plus 70 is equal to 180 degrees, and then you write op angles of cyclic quad. Then what do? We solve for x. We transpose the 70 degrees. What's 180 minus 70? X is 110. Okay, you could also just go ahead and just say x is equal to 110 and write the reason. Either or, that is fine. One is short, you know, and the other one is also maybe short, just 2 steps. All right, but you are able to actually work it out and see x plus 70 degrees or to 180. You transpose the 70, you get x is equal to 110. So thank you so much, guys. I hope now we see that what absolute rubbish for sir to say x is equal to 70, because that can't be true. We know that opposite angles of a cyclic quad are supplementary. What about y? So I see Gladys there already gave us our answer, and some of you did as well. So y, guys, is equal to 100 degrees, because it's 100 plus 80, that gives me 180. That's what makes it supplementary. Opposite angles of cyclic quad. Okay, thank you. Are we together now? People questioning the entire experience. I hope now we can see, oh, okay, no, sir, we understand, we are okay. We are finally at peace. There's no war in our hearts. All right. So yes, you update. X is equal to 110. Y is equal to 100. That's why you guys need to be so clear with your understanding of the theorems and what they say, so that you don't confuse somehow. Like you can see here, this fact that no, opposite angles are equal. No, guys, it's not opposite angles are equal. It's opposite angles are supplementary. This is a cyclic quad. Okay, let's look at another one. Here is the circle. There is the diagram. There is B. There is A. This is the letter Z, letter Y, 54 degrees, X, 80 degrees. You are required to find the value of X, Y, Z. Now very quickly, when I look at this diagram, what do I have given to me? Angle B is 180, angle BAC is 68 degrees, right? And angle DCA is 54 degrees. So which letter can I find straight away? All right, what are you guys thinking? Let's see in the comment section. Okay, we have X. X is in this triangle. Y, real gift is saying Y is 100 degrees. Do we agree with real gift that Y is 100 degrees? Can we write that? Y is 100 degrees. Do we agree? And what's the reason for saying Y is 100? Y is 100. Okay, I love the Y idea. We can Y is 100. What's the reason, guys? Do we know? Angle B and angle D, the quadrilaterals. Okay, Gladys is saying the quadrilaterals. I see we've got a judge of all sorts here with the jury and the, yeah, his little house of lawyers. Yeah, Y is 100, but why? Presh is also agreeing that Y is 100. Angle D and angle B, thank you Idumeleng, opposite angles of cyclic quad. So yes, op angles of cyclic quad. Remember, this answer has no weight if the reason is not there. Thank you, Don Chabalan. Okay, update the diagram. We have 100 here now in the place of Y. What's the next thing we can find? Using what can we find what's missing? What is the next thing that we can find? We can find, okay, we can find X definitely, but Presh, where are we going to look when we find X? Specifically, what are we looking at here? Because we've got the quadrilateral, which is a cyclic quad, but then we have 2 what inside the cyclic quad. Very good, Presh. Thank you. Sum of angles in a triangle. Interior angles of a triangle. Sum of angles in a triangle. The triangle. Which triangle? So in triangle BAC, let's go and specify the triangle so that we can have the liberty. What do we know? X plus 80 plus 68 is equal to 180 degrees. Reason. Int angles triangle, or we could say sum of angles in a triangle. Either way, doesn't matter. X is equal to 180 degrees minus 148 degrees, because that's what 80 plus 68 is. What does that give me? It gives me X is equal to 32 what degrees. So X is 32. Update. Done. I repeat, we can see there's a missing angle in triangle BAC. So that's why I use sum of angles in a triangle, interior angles of a triangle. I add my angles in this top triangle, equate to 180 degrees. I solve for X. Okay? So X is 32 degrees. Now, who's missing? Which letter? Letter Z. What can we do to find the missing letter Z. What are people thinking? We have Y here, which is 100. We have the 54 degrees. We have Z there. Okay, real gift is saying Z is equal to 26 degrees. Guys, you know we can do that. We can just say Z is equal to 26 degrees and then write int angles triangle, or sum of angles in a triangle. Okay, some people insist on writing out the statement equating to 180 and solving. But even if you said you noticed, you know, using your that it's 100 plus 54, what's missing to get 180? You just say Z is 26 and you write the reason. Okay, now some of you may be like, "Hi, will I get all my marks?" Definitely. Statement, reason, statement with its reason, okay, and then your statement with your reason. Okay, nice marks, ne? All right, yeah, nice. Yeah, when your paper is like this, okay, and you are getting all these ticks, it's such a good feeling, eh? It's good, so nice. All right, I hope you guys are fine. If there's any questions, I'm hoping I'll get some. Now it's time for me to give you your game challenges. I hope these two examples prove very solid. Wait, in fact, just before I give game challenges, let's see if we can't venture and do 2 additional challenges. I mean, just 2 additional examples, so that we can explore the full scope of the theorems that we did. Let's do a third one. Tatejo, what's the problem? You seem to be crying there, tears of joy. Or is it tears of joy or tears of sadness? You said 26, question mark, issues. Tatejo. What's happening? What's happening, Tati? Are those tears of joy or tears of sorrow? Explain to her again why Z is equal to 26 degrees. Okay, all right, let's go back a bit here. The diagram that we had, guys, was you see now the diagram is no longer clean. It is dirty. It has been tainted. Let me try and redraw it. So I'm guessing some people, they joined in late and now they are okay. Let's redraw this diagram for the benefit of those that came in a bit later. Because this is how the diagram looked. We had angle B, angle A, angle D, angle C, right? So we started off, or at least the people started off, they looked at this quadrilateral. Why quadrilateral? Which is in a circle, and it's called a cyclic quadrilateral because all 4 vertices are on the circumference of the circle. Grade 11 and 12. Then they said y, that's the first thing they did. Y is equal to 100. Why do we say y is equal to 100? What is the relationship between angle B and angle D, since they are at the circumference of the circle and they are in a cyclic quadrilateral? We know that angle B and angle D, they add up to 180. So what would y have to be in order to make up a sum of 180? Y would have to be 100. So to the person who was asking, where does the 100, why is y equal to 100, where does that come from? It comes from the fact that the opposite angles of a cyclic quad are 180 degrees. So y is equal to 100. The reason? Opposite angles of cyclic quad. Okay, we move on to the next thing. We update whenever we get an answer that's correct. We update the diagram so that it has the updated information. It's like your phone. It also updates the minute it has updates that it needs to do so that it can function more effectively and it can serve you better. So this diagram can now serve you better because you've updated it with the new information. 100 degrees. Then when you look at the diagram again, what can you now find? Can you find x? Yes, you can. But what do you use to find x? You look in triangle BAC. What do you know about these three angles inside the triangle? The sum of the angles in a triangle, they add up to what? 280. So that's why they said x plus 80, which x? X plus this 80 plus what? Plus 68 is equal to what? 180 degrees. What's the reason? Sum of angles in a triangle. Or you can say interior angles of a triangle. Or you could just write the answer. In your calculator, you're going to say 80 plus 68. You know it's 148. Okay? Then you subtract from 180 the 148. Okay? And then you get 32 degrees. So you could have said x is equal to 32 degrees and write the reason. Or you could go the long route. Give the statement equal to 180, then you solve, you get x is 32 degrees. Either way, okay, it would have been okay. Then, to get z, to the young lady that was crying tears of joy or tears of sorrow, that needed explanation again, this triangle ADC, this one, is missing angle z, which is this angle. So therefore we say z is equal to, remember the sum of the angles of this triangle gives you 180, this is 100 degrees, this is 154, this is 54 degrees, 100 plus 54 is 154. What are we missing in order to get 180? That's why we just simply write z is equal to 26 degrees. We know we got that by interior angles of a triangle, or you could say sum of angles. I mean, it doesn't matter whether you use sum of angles in triangle, that's also fine. Okay, so yeah, this is just quick short way of being able to just write the answer without really writing the statement, the long statement equal to 180, solving and all of that. You could do the solving, that's fine, you can stick to that. I have no problem with that. You can do that, write the statement equal to 180, write the reason, solve, get the value. Or you can just ask yourself, okay, in this triangle, I know the sum of the angles adds up to 180, but what is z? If these two add up to 154, what do I need to get 180? Z needs to be 26. You can do that and then write the reason. Done. Okay. All right. You can do that too. So yeah, remember Euclidean geometry can be quite, you can spend a lot of time thinking. But once your thought process has been sorted out, your obligation is to ensure that you write the correct statement, further supported by the correct, acceptable reason, so that you don't lose any marks. Right, so I hope we are fine now. Thank you. I hope even my crying daughter there was a crying daughter that came here, was crying very hard. I don't know if it was tears of joy or tears of laughter or tears of sorrow. Tatejo. If Tatejo is fine, hopefully you can let me know in the comment section if all is well. If not, please let me know. If I'm going too fast and you are lost, please let me know. If you don't know what's happening, please let me know. If your name is 100% for maths, please let me know. Okay, 110 degrees here. We've got A, we've got D, we've got B, we've got C, we've got X. They want the value of X. What do you say? First example. Okay. What are the people saying? What are the people saying? Okay, what are the people saying? 110, Gladys is saying. Renelli was saying x is 110, right? Can we all agree that x is equal to 110 degrees? All of us, are we agreeing? X is equal to 110 degrees, indeed. And our reason for saying so? Exterior angle of cyclic quad. Okay, very important. There's someone who's saying in the comment section, don't you first find angle C1? Okay, now people, does an angle C1 actually exist in the diagram? That's the question I want to ask. Okay, remember, if you are dealing with a rider and there is no 1, 2, 3, you don't put in 1, 2, 3. We don't do that. Rather, if you want to tell me, don't we first find this angle on this side, then you have to actually do this thing and say angle DCB, that's this angle. Or you can say angle BCD, that's the angle. You can't say this is C1 because you were not told in the diagram, it was not given as C1. Thank you so much, Lungisani, for the 5 roses. Much appreciated. Okay. Thank you, Don Chabalal. We only construct when proving theorems. That's why I'm saving the proving of theorems for last. I do not want to have my learners confused whilst we are dealing with riders. You know? So that's why I'm reserving the proving of all the theorems, at least the ones that are examinable, because those are the only ones I'm going to be proving. When you and your teacher will prove all the theorems at your school, I'll be happy for you. I'll rejoice for you when you do that. But moi, Mr. Maths Gamer, in this platform will only prove the theorems that are examinable only. All right? Please, this is angle DCB. This is angle BCD. You can either say it's DCB or you can say it's angle BCD. Don't say this is C1. Don't introduce a 1 or a 2 when the 1 and the 2 was not there. Okay. Lihle spams. Your teacher is right, Galogo. Like I said, you see me, I'm not playing the role of your teacher. Me, I'm playing the role of someone who has a Maths gaming channel on TikTok. All right. And there are just certain things that I'm saying that I am not replacing or displacing the role of your teacher at school. Me, I'm just here to really try and make things accessible, easy. Maybe also just, give you, some other ways or alternative ways, call it what you want. Ultimately, I'm just here for that. And I'm just here to also fuel the fire of the passion that I have to assist and help learners across the country because of information that I have. And probably even of ways of explaining certain things that may be more accessible to some of the learners, which they may find easier to grasp. That's all I'm here to do. I'm not here to replace or displace your teacher. Please, I'm not here for that. And please don't go to your school and then say, no, that guy from TikTok, guys, I don't want like that. I don't want things like that because I don't want your teachers coming and inboxing me here and saying, hey, you are that guy. Please keep my name out of your mouth there at school and stick to the knowledge that you have. And I give your teacher the rightful place that he or she deserves at your school. So x is equal to 110. You are right. Exterior angle of cyclic quad. Thank you so much. That was beautiful. Very well done. There's one more. 105, 88, y, x. Yeah. Don't want those inboxes. Please, you don't want inboxes. C, D, E, B. This is 88 degrees. This is 105. We want x and y. What are my people? Where my people at? Where my people at? All my people stand up. All my people stand up and tell me the answer so we can move together. Londani, thank you so much. Londani in the comment section saying x is equal to 88 degrees. Do we agree with Londani? Londani, I agree with you wholeheartedly. As Azanda, I see you as well in the comments there. All right. Okay. And then someone else, Reneli, was saying y is equal to 105 degrees. Thank you so much. Now I need reasons for the things that you've said. Let's first start there. X is equal to 88 degrees. Why? Why is x equal to 88 degrees? Okay, my people agree. Oh, my people agree. Oh, my people agree. Oh, my people agree. Okay, nice. Ext angle of cyclic quad. Ext angle of cyclic quad. Oh man, science genie. How's it, buddy? How's it, mate? There we go. All right, I think game challenges now. You guys are you are ripe. You are ripe for game challenges now. You are so ripe. It's like it's fruit that I'm ready to pick from the tree. Okay. Yeah, guys, there's merit in seeing things demonstrated in front of your eyes by a teacher. You know, obviously sometimes in conjunction with other learners assisting, it's good to have that demonstration done in front of you. Then after that, you can be given game challenges to do, and then you can test yourself to see, did I really grasp that concept? You know. So that's fine. Okay, there we have it. Game challenge number 1. Look at these people. Look at these people. Already people are like answering it up. Okay, always the center, ne? There's something for you guys to note. Always the Z center, that's Z, that's X, that's Y. C, D, E, B, A. All right. The boy next door is saying x is equal to 120. Opposite angles of cyclic quad is opposite interior. Hey, the boy next door, please, your reasoning needs to be, please take note. Please take note. This is what Don Chabalala was emphasizing there in the comment section to Vincent. I want to pin the comment. Please, guys, give reason as exterior angle of cyclic quad if it's exterior angle of cyclic quad. So for instance here, 120 degrees. Remember, this is the exterior angle of cyclic quad. Are you with me? Okay. So like I said, in every diagram here, O is the center. Okay, what I'm gonna do, I'm gonna turn off the comment section so that people can be busy whilst not seeing what other people are saying. That makes life very interesting. Okay, This is 125. Then I'm going to call on some people to come, right? I'm going to call on some people to basically come on and guide and lead me to answering the questions. How's about that? I think that can be more fun and interesting. I guess 11 o'clock will be the cutoff time. I'm going to leave you at 11. I think that will be enough time. I will have given you sufficient time to be with me in the live, the game challenges. But let me first write down all the challenges so that no one has an excuse for waiting and wondering. And I'm sorry if I'm writing the drawings small. We want X, Y, and Z, okay? Okay, so these are the, yeah, I guess this is the entire, I just want to give maybe even people the chance to want to screenshot the opportunity to do so, just without the words being there to interfere, because, yeah, there it is, guys. I guess those, the screenshot has, this is A to I. So I want us maybe to do the first, just some of them. But yeah, I want to see if there's any brave people. To, I'm not gonna tell you which problem, but anyone who's brave enough, you can request, and then you can hop on, and I'll decide in the moment when you request which problem I'm going to ask you to do. So it's not going to necessarily be A, it may be H, it may be E, it may be any other one of the above. So let's give my good people a chance. You can request. I will be more than happy to have you up. The request is for you to request, and I'll accept. We can talk about it. Seems Mr. Vincent, Mr. Vincent, been wanting to hop on for a long time now. Mr. Vince, how's it, Vincent?
Hello, guys.
Hello, Vincent.
Hello, guys.
Hello.
Can you hear me?
Yes.
Hello. Can you hear me? Oh,
Yes.
Okay. Sorry, I was connected to the Bluetooth via the speaker, so I just switched it off.
No problem. Are you ready to help us with one of these?
Okay, I can try.
Are you firstly in either grade 11 or 12? I don't want varsity students coming here and stealing the show.
I'm in grade 11.
Nice. I get. You are the right person. All right. Vincent, let's come here at H. I think
At H, okay?
H is calling for you. It's calling your name.
Okay. I would definitely say, is it Q?
So this
QPSR.
is QRS, yes. And then that's
Yes.
A, that's B, that's 92, that's 112.
Okay. We can definitely see that SRQP is a cyclic quad, isn't it?
Amen.
Yes. So definitely I would say B plus 92 equals to 180.
Okay. I like that.
Am I correct?
I love that. B plus
I need
92.
you to confirm with me, sir.
Nice. Very good. 100% correct
Opposite
so far.
angles of a cyclic quad.
Amen.
The reason?
Yes. Very nice.
Okay. Therefore, I go to the other one. 112, is it 112? Yes, 112 is equals to.
Okay, just hang on a bit, Vince.
Can I please see the diagram? I can't see the diagram.
Yeah, just before that, there's a reason why I'm running away from the diagram. You said B plus 92.
So B is equals to 180 minus 92.
Thank you.
Sorry, I kind of...
No problem.
So B will be equals to... What is the value? I don't have a calculator with me. Sorry, I've left it in the other table. Can someone please give me the answers? That will be 88. Okay.
Degrees.
Okay, thank you, sir.
Thank you.
The
That
diagram.
was correct statement, reason, answer. Thank you.
Okay.
Back to the diagram. So we update B is 88.
88.
Yeah.
So A will be equals to 112.
Okay. Reason?
It will be exterior angle of a cyclic quad.
Thank you. Yeah. Hi, Vince. Are you sure you're not that guy, the one who was in WWE? Is it Vince McMahon?
No, 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 no.
Oh, okay.
Definitely not.
Yeah, no,
Okay.
it's like you are a Euclidean geometry WrestleMania coach, if you know what I mean. All right. No, that's spot on. Thank you, Vincent. I think I'm going
Okay,
to
thank you.
gravitate towards one more for you, Vincent. You know, like bonus,
Okay, sir.
bonus stuff, if you know what I mean. We are here in this diagram, Vincent.
Okay, is it G?
Yes, G.
Okay, sir. For G, we don't have a cyclic chord. Is it OA is equals to OC? The way I'm seeing?
OA is equal to OC. What's the reason?
Is it ready?
Okay,
I want you to
OA.
confirm with me. O is the center, isn't it?
Yes, O is the center. These two are equal. Yes, that's true.
Okay. Then definitely would have 150 plus Y, if I'm mistaken. 150 plus Y, is it not co-interior angles?
150 plus
Y
is equal to?
180 co-interior angles, if I
Oh, I
made a
think I
mistake.
forgot there to write these parallel lines. True. Okay, sorry about that. So that's not clear. I didn't write the parallel lines.
Okay.
Okay, so you were
So that would
saying
be 150 plus Y
150 plus y. True. 150 plus y.
equals to 180
Very true. Is equal to 180.
co-interior
Co
angles.
int
Interior angles.
angles. Yes.
Therefore, it will be 180 minus 150, that is Y.
Okay, just hang on. I want to go back to your reason. You said 150 plus y is equal to
Equals
180
to
degrees.
180
And then you said it's?
co-interior angles.
Yes, co-interior angles, I agree. I
And
guess I'm
then
going
it will
to...
be Y is equals to 180 minus 150.
Okay, go back again. You see, there's something I was waiting for. I thought you were going to say it. You said co-interior
Okay.
angles. I agree, but there's something missing here.
Co-interior angles of a cyclic. No.
No.
No, of a, is it a parallel?
When you say co-interior angles, what else must
Wait, let me
feature?
check the shape.
That's
Is
besides
it
the
two
shape. What
sides
else?
equal?
What else must feature when you write the reason co-interior angles? For your corresponding angles, alternate angles, and co-interior angles, there's something else that must also feature
OA
along.
is equals to, so OA is equals to BC, is it not?
OA is
OA equals to BC, is it not?
equal to BC.
Parallel lines
OA is?
equals to O. I can see the diagram.
OA is?
Yes, parallel to BC.
Yes, thank you.
Yes,
So that's the
sorry.
thing.
It slipped my mind, that one. Sorry.
No problem. That's why we are here, so that even for someone else who it may have slipped
Okay.
its mind for, who is watching in the live, they can also be aware, oh, hey, I have to make
Parallel
sure
lines. Okay.
that I write my
Sorry.
parallel lines. Your reason is full only when you have the parallel lines
Parallel
as well
lines.
accompanying co-interior
Yes.
angles, whatever the case may be. Okay, so yes, so you can
Okay.
continue.
Then Y equals to 180 minus 150.
180 minus 150, spot on.
That would be 30.
Thank you. 30 degrees. So I have 30 there, 100%. Moving right along.
Therefore, it would be Y plus X.
Y plus X. This one.
That would be, yes.
Okay.
That would be equals to 180.
Okay, and what would be the reason? Y plus x. This angle and this angle.
Would it not be still co-interior, or there's another one?
Okay. So the thing is, if you say co-interior, remember we need this line and this line to be parallel. Is this line and this?
So yeah. I wasn't checking. Okay. So definitely that would be 150 plus x. Sorry.
150 plus x.
Plus x.
Is what? What about 150 and x?
They're equals to 180.
Okay, if you're saying they're equal to 180, why would you say that? What's the reason?
Let me check first. I cannot say that's a cyclic quad, isn't it? Because
no,
all the 4 points are not on the circumference.
Very good. I love that, Vincent. Vincent, I love what you just said. All right, because you see, the thing is, Vincent, for most people, what you are saying, it may seem like it's something small. It's big what you've just said. And I love the fact that you said initially, can I say ABCO is a cyclic quad? And then you concluded on your own, no, it can't be. Why? Because not all of your vertices are on the circumference of the circle. So therefore, cyclic quad. So thank you for that. And thank you for saying that and voicing it out as you were thinking. It's beautiful.
Okay. Let me see.
So what else is there?
Okay, can I please just check?
Sure, you can check. Let's see if there's anyone else maybe that can also assist you as you go along. But you can think about it and check.
Let me check. 150 and x, the relationship between the two, right? Definitely, I cannot say corresponding. Nope.
Okay, so I've allowed someone else to come on as well, and just to see maybe
somebody
if they can also assist us.
Can someone assist me?
Okay, we will say angle AOC, the exterior.
AOC. What about AOC?
Yes. Equals 210 degrees.
AOC is 210 degrees. I'm guessing you're talking about the reflex.
Exterior. Yes.
Or the reflex. Okay. So AOC,
yes, and then the reflex
angle
angles around a point.
Oh, yeah.
Oh, 210 angles around a point. Okay. Can agree with that. 210 here.
And then x will be 105 degrees.
Okay, x is 105 degrees. Why?
Angle at the center equals 2 times angle at the circumference.
Okay, angle at center equal 2 times angle at circumference. Okay, wow. All right. So here we had to actually take into consideration the fact that this is the diamond that's kind of like 3 vertices at the circumference, 1 is at the center. So that's angle at the center. So we had to find the reflex angle, which is 210, using angles around a point, and then use angle at the center, this one, because the arc AC subtends this angle at the center, and the same arc subtends angle B at the circumference. Okay, beautiful. Thank you so much, Vincent. Thank you so much, Gift, for helping us out with the conclusion of that particular problem. Vincent, I hope at least even get the assistance there, the coming in of Gift, sort of like also help to unlock maybe that theorem you've forgotten. Because that's the thing, right? So in our minds, I'm sure, because we've done cyclic quad, we're busy with cyclic quad theorems. maybe we do not sort of like have in the forefront of our head the other theorems that we've just done. So it's just they've integrated, just so that you can also recall those ones now, yeah. Otherwise, that was nice. That was cool. Okay, I think Vincent, if you will allow me, sir, let me let you go. Let me continue with Gift and give him his own special one. Thank you so much, Vincent. Really appreciate you.
Thank you so much.
Sure, buddy. Sure. Gift.
Yes, sir.
Yeah, the only gift in the world. Easter is coming. There was a gift that was sacrificed. I don't know if you are that gift here. The gift for the people. All right. So, Gift, could you help us out with this one?
Okay.
Yeah.
So x is 98 degrees.
X is?
X is 125 degrees.
125
degrees.
Okay, X is 125 degrees. How?
Exterior angle of a cyclic quad.
Okay, all right. I'm just trying to check this quadrilateral first, the one that is inside that has 4 vertices. So it's EDCB. That's the quadrilateral, right?
Yes.
That has 1, 2, 3, 4 vertices at the circumference. 125 degrees is this angle. It's external because it is in line with the side of the quadrilateral. Oh, so you see, okay. So this exterior, this is the interior opposite angle, the X value. So you said that X value is equal to what, Gift?
125 degrees.
Nice, okay. All right, I agree. I think at the beginning I was like, how? All right, now I see. So X is 125 degrees. Thank you. And the reason you said is?
Exterior angle of cyclic quad.
Exterior angle of cyclic quad. All right. Okay. Update. Just that obviously this is a bit cramped up. Sorry, because my diagrams are very small. Okay. Y and Z.
And then Y is 90 degrees.
Y is 90 degrees. Why?
Angle in a semicircle.
Angle in a semicircle. What are you seeing?
So BE is a diameter because it passes through the center.
Oh, all right. BOE is a diameter, passes through the center. Yes, I agree.
So angle Y will be 90 degrees.
Oh, okay. Because it's subtended by the diameter at the circumference. Okay. No, that's fine. So Y is equal to 90 degrees. And you said angles in a semicircle. Nice. Thank you, Gift. That was, yeah, that's true. I agree. Now we are missing a beautiful Z.
So angle B1.
Okay, B1, yes, that exists.
Equals 55 degrees.
B1 is equal to 55 degrees. Now that should be interesting. Angle B1 is equal to 55 degrees. How so?
Angles on a straight line.
Angles on a straight line. Oh, this guy and this guy, they're angles in a straight line. Nice. So okay, that I agree. Angles on a straight dot line. Okay.
So sir, will I lose marks if I just write final answers?
Would you lose
marks
if you wrote? How? What do you mean if you wrote final answer?
Okay, because others they will say 125 plus B1 equals 180, and then they give a reason.
Yes. If you write B1 is equal to 55 degrees, you won't lose marks.
Okay.
Yeah, you won't. All right. Yeah, it might just be. It's even with co-interior angles. For instance, you remember when we did when I think it was earlier on, Vincent, when he said 150 plus y is equal to 180 degrees. It's like you could say y is equal to 30 degrees and write co-interior angles. OA is parallel to BC. You won't lose marks if you just write the variable and its value. All right, you won't. It's 100% fine.
And then angle Z equals 35 degrees.
Okay, angle Z is equal to 35 degrees. Reason?
Sum of angles in triangle.
Okay, sum of angles in triangle. So I'm guessing you are looking at that 90, at that 55. What is missing? So 90 plus 55 is 145. Plus what gives you 180? So you just said Z is equal to 35 degrees, sum of angles in triangle. Perfect. My leader, it's perfectly fine if you write statement, reason, statement, reason, statement, reason, statement, reason, without actually writing that statement where you have to then afterwards solve. 100% fine. You can do that. No marks will be lost. You will get all your marks. Okay. Gift, thank you so much. I think my leader, you have done the things.
Thanks.
Thank you. Let me see if we can get someone else. Diversify. People are gonna say that, hey, I'm just inviting the guys here, but you guys don't understand. It's the guys that are requesting. That's why. For instance, this one even has that name that would suggest guy. I mean, you know, when someone is called Mfana, then it's finished. It's finished. Yeah, hopefully he picks up because connection right now. Mfana.
Yebo.
How are you, Mfana?
Ngiyaphila njani malum?
Ngiyaphila Mfana. Oh, that name, bro, that name. You are the main man. You know, most if they say you're Mfana, then it's done. It's finished. It is finished.
Yes.
Yeah, man. Let's keep it real. Let's kick it. Let's see. Here is D for you, Mfana. What do you have to say? You are given the angle there, 110 degrees. Then obviously you want X, you want M, you want Y. So the information that you have been given is just that, and you want X, you want M, you want Y.
Okay, Kimbo. X, okay, okay, last, X plus 110 is equal to 180.
So repeat, you're saying X plus 110 is equal to 180. Is that what you said?
Yes.
So this X and this 110 is 180. Why? What's the reason?
Imali ngicela ukubuza la.
Buza.
Sinike u110 kuphela.
Only. And then
okay.
Yeah, and then you have all these symbols which would mean something to you, and then these ones which should also mean something to you.
Okay. PT is equal to LPS. Okay. Oh, okay. Okay, ngasho ukuthi 110 plus y is equal to 180, opposite of a cyclic quad.
110 plus
y.
Okay, is equal to
180.
What's the reason?
Opposite of a cyclic quad.
Okay, so let's
supplementary.
So I'm hoping your reasons will be obviously in line with that document, those acceptable reasons. So we write op angles of cyclic quad. That's enough.
Yes.
Okay.
Yes.
This is just the short version of the reason. Okay. Op angles of cyclic quad. Okay.
Yes.
Then
we transpose 110.
Very true. Which gives us an answer of what?
110, which means we're gonna get 18 minus 110. So thola 90. I'm not sure, but it's not 90.
180 minus 110 is 70 degrees.
70, yes.
Yeah. Okay. So that means we have y. Y is 70.
7 degrees.
Okay. Now we need x and m.
Okay.
Okay. Well done, by the way, for getting the first one.
Okay. The 10, okay. And 10. Okay, y. E. Okay, balingana lava. It's 70 m lona. Okay.
Okay, it's always nice to have some lifesavers in the mix, just in case.
Yes, eh?
Hello, Crash.
Hi, sir.
How are you?
Hi, Bo.
How are you, Crash? Hello. Hello.
Oh,
Hello, Crash.
hi, sir.
Can you hear me?
Yes.
Yeah, we need a superwoman with a cape. Do you perhaps possess such?
Okay. Yes, I do.
Oh, okay. So we want the value of
Okay.
x and m.
So we start with the value of x, right?
Sure.
So, angle STP
Yes.
is given that it is equals to it's gonna be equals to the side TP, it's given that is equals to PS, right?
Okay,
Which
TP
means
is
angle
equal to
PS
Yes, that's
TP
given.
it's given, right? Which means angle STP it's
STP.
equals to it's equals to angle TSP.
Okay.
Right, the reason will be angles opposite equal sides.
All right. Nice. Just hang on a bit. Thank you so much. Really appreciate that. I just want to check with Mfana. Mfana, does that make sense to you for that triangle PTS? You see what
Yes.
Precious said? He said PT
Yes.
is equal to PS. That's
Yes.
given, Mos.
Yes.
Yes. Then angle STP, which is STP, is equal to TSP. And they're both equal to x. And the reason is angles opposite equal sides.
Side, yes.
Yeah. All right. You can continue, Presh.
And then in that manner, we'll say 110 plus 2x is equal to 180. The reason being sum of angles in a triangle.
All right.
Therefore, x is equals to 35 degrees.
Okay, sure. All right. Yeah. So that was Presh doing her thing. I could see that Superwoman cape was definitely on. So yeah, that's how we get the value of x. 110 plus 2x is equal to 180 degrees. Sum of angles in a triangle, and of course then we can then get transpose. When we transpose and divide by 2, we get x is 35 degrees. Okay, 100% spot on. Did not even miss a breath there. Okay, mfana.
Yeah.
The song.
Yes, I sunk.
Oh, okay. Do you want to continue, mfana, or must Presh finish off with her Superwoman cape?
Let me try.
Okay, all right. Presh, are we fine with that?
Yes.
Okay, show mfana.
Okay, sinangi sesinaye u-x u-35.
Yes, so we update, there's 35 there, there's 35 there. Updated.
Okay, sesingasho ukuthi u-m is equal to 35 alternating angle.
Okay, hang on there. So you are saying m is equal to
35.
which 35? This one?
This one, yes.
Okay. Now my question is to you, mfana. If you are saying m is equal to 35 and you are saying alternate angles, my question to you is, where are these parallel lines for the diagram so that you can say what you are saying? Remember, most that alternate angles that are equal exist between
the parallel lines
that are parallel. If they are there, what's beautiful is that in your reason, you will say m is equal to 35, you'll say alternate angles, and you will also write down the lines that are
parallel.
So I'm asking you, where are the lines that are parallel? Oh my God. Oh, you know what?
Hey, Presh. Hey, Presh. Hey, my keeper. Oh, Jesus.
Presh, is your networking, or is it giving? Yeah, I think you've heard Mfana there. He's declared all sorts of things. Yeah.
So I should continue.
Yeah. Yo.
I should give him a chance again with a little hint.
Okay, sure, go ahead.
So the hint, mfana, is that to find m, you are doing exactly what I did to find x. That's the hint.
Okay. Shows singasho ukuthi angithi we given ukuthi SR is equal to TR.
Yes, indeed, we are fine. SR is equal to TR. That's given.
Which means u angle S will equal to the angle T.
Okay, now we need to be careful about that blanket statement, Fan. Angle S is this entire angle. It's everything here. It's everything.
Okay.
So what do you mean?
Oh, which means singasho ukuthi angle M is equal to angle T, because
once again, angle T is this entire thing. And my hope is that those who are listening as well, because you see what you are saying, Mfana, is something that learners commonly do when they are referring to angles. And the only way you could actually say what you are saying is if you had prepared the way and said in triangle. If you do this, if you say in triangle TRS.
Oh, yes.
You see, when you say to me in triangle TRS, My attention now is focused in the triangle. Now
Yes.
you can easily say to me, M, which is there, is
Yes,
equal
is
to
equal
T,
to
angle
T.
T. You see, you can say that.
Yes.
Yeah. Or you can say angle T is equal to angle S because you've told me the triangle where you are working. But if you don't tell me the triangle that you are working, then you must do the naming of your angle according to how Presh did it in the previous example. You must use the sides. This is STR. This is RST. You must use that name of being able to identify the angle. If you do not tell me the triangle. And these are important things because in the exams, when you write and you are marked externally, if you don't care about these things, you will lose marks. You lose marks unnecessarily.
Yes.
Yeah, because you need to be specific, you see?
Yes.
So yes, if you say in triangle TRS, then you can say M is equal to angle T or angle T is equal to M. What's the reason? Angles opposite
Opposites.
equal sides.
Yes.
Okay.
Which means there's no M about 2.
Amen.
Shuthi sesingasho ukuthi 2M 2M plus 70.
Yes.
70 is equal to 180.
Very sweet.
Interior angles of a triangle.
Very true. Interior angles of a triangle.
Yes, and then we solve for M.
Amen. You tell me. Let's go ahead. Let's solve for it. So how do we go about it?
We transpose 70.
Transpose the 70, 180 minus 70 degrees. True.
So sala no 110 kwa right hand side.
Very true.
And then we divide it by 2.
Very true. So M is equal to what?
So sala no ukuthi calculate ayikho eduze kwami kodwa uma ngicabanga 60. I'm not sure.
50.
55, yes.
Okay. All right. Yeah, Mfana. No, Mfana, we are getting there, aren't we? Hey?
Yeah.
Yeah. There must be light. These things, as these things get revealed and we understand the better way to do the things, then we must do those things in that better way, and we should be fine. Moving forward.
Yes.
Yeah. Otherwise, thanks, Mfana, and thanks to your lifesaver there, Presh. Yeah.
Thank you, Presh.
You're welcome.
Okay, guys, that was sweet. That was nicely done with the both of you. Thank you so much. I think I'm actually going to hold it right there. The rest are for you to do. The rest are for you to do.
Sir, can I ask you a question?
Sure, please go ahead. Maybe Presh can even answer your question.
Yes. How to master a Euclidean geometry?
You must have an open mind. Euclidean geometry. If unavele mawubukile ucabanga all the possible reasons, what do I have? And if you buy color pens, so that in your shape you can see that I've got this. So when I work on this, I must get this one. This one will lead me to that. It's a workshop. But you need to understand. You must not cram. You need to understand what's happening and why is it happening.
Yes.
Yeah.
Hayi umuntu kusamele aqale ayazi.
Yeah.
Because ka grade ngenza grade 11 manje ya grade 10 like ngangibhala kodwa like ezinye izinto sengayikhola kusamele ngiqale like ngibuyise. Sekuningi kakhulu futhi kwamanje yabo. Kodwa sazosebenza.
Yeah, awuzayisebenza mfana. It's important futhi the basics of grade 10 are important too, because what you are finding, for instance, I'm thinking of the problem that Vincent was doing. All of a sudden we have the relationship of parallel lines. You learned about lines and parallel lines in grade 10. If Vincent had forgotten those, then he wasn't going to be able to get the value of y in this diagram, because there's no other way besides knowing the relationships between parallel lines. In the problem that you and Presh did, you see that there's that relationship of the triangles. You need to know the theorems that relate to triangles, the angles opposite equal sides. You see, if those things you've forgotten them, those were grade 8 and 9 concepts that you did. So you need to also cover up that content and make sure that you know all the theorems. That's why, for instance, with the grade 11 now, as I'm helping you guys kind of go through the grade 11 content, I am going through each theorem. I'm reading the statement with you. I'm unpacking what the words mean of the statement. And then I am going to the diagram and I'm showing you what does the diagram look like for line from center perpendicular to the chord bisects the chord. What does the diagram look like for line from center to the midpoint of the chord is perpendicular to the chord? What does the diagram look like for arc that subtends an angle at the center? Is that angle is equal to the angle subtended by the same arc at the circumference? Which diagrams inform that theorem? What do those diagrams look like? Do we know the bow tie diagram? Do we know the diamond diagram? Do we know the arrowhead diagram? So all of those things, we are trying to use a day and cover single theorems so that we go through problems, you do the problems, you are able to sort of like, get that theorem in your head through the problems as you do them. I'm doing simplistic problems on purpose, deliberately, so that ultimately when we get to a place now, when we've done all the theorems and I say, let's go and look at exam type problems, now you'll see a mix of things there. But you see, the thing is, like I said to Elena yesterday, I said, it's like, for instance, Mfana, who is your favorite singer at the moment? You love music most, there's no doubt.
Hayi mina ngiyibhinca.
Uyibhinca?
Ngiyibhinca mina, hawu. Mina ngiyibhinca, hawu.
Uthina ngoku.
Ngiyibhinca mina ngumZulu.
So that means uthanda yintoni khona le niyithanda nyani pha? Umaskandi. Yo. Ngubani?
Uparis. Nabo iParis nabo bafika izola basuse.
Yakuxeyelela. Mamela ke mfana. If you can think of one Maskanda artist, for instance, mhlawumbi uthanda ubani kukhona umuntu ongumthandeni? Yeah, sensitsho ke whoever. If let's say for instance that guy lands at your school, let's say at your school you have 1,000 and so learners in your school. If umthandeni comes to your school, I'm sure if you know the guy and you know him very well, you would be able to identify umthandeni in the crowd of 1,000 people. You can see, because you know umthandeni, you know his face, you know how he looks, you know everything about him. Kaloku wena une obsession about umthandeni. This is kind of like the same concept, the same principle I would like to sort of like infer when it comes to these individual theorems. If you know the statement, you know the diagram, you will be able to identify a certain theorem and know how to apply to get a certain answer because you know the diagram. So it may be a diagram that has many lines, and it's like, yo, this is so complicated and complex. But because you know these individual theorems and you spent enough time with them individually, you'll be able to identify them in the midst of many lines and many circles, you see, because you know it. So just like you know how to identify umthandeni in the midst of a crowd. So that's why I'm saying, guys, spend the time, as we are doing this. I know some people are getting agitated when I'm doing this, like basic problems. Like some people are like, I will say, when are you going to get to we want exam type problems. I'm going to take my time. Let's cover the individual theorems. Be sure about the individuals first. You'll see when we get to the other things, even the exam type problems, they are easy. But first,
Yes.
we must get the foundation right. So grade 10 and grade 8 and 9 geometry, those quadrilaterals, those properties of the quadrilaterals, those properties of the triangles, knowing the lines, angles on a straight line, they are supplementary, complementary angles add up to 90 degrees. When you talk about bisecting lines, it means that you have a midpoint of a line. So therefore, this is equal to that, that is equal to that. These things are important, all of them. So you must know them. And when you know them, I'm telling you, the geometry becomes nice. It really becomes delicious when you know them. And you know the acceptable reasons that you need to attach to a statement. I don't care who you are. You will be fine. All right. So one step at a time. One step at a time. So when you join my live session, we are going through them.
Yeah.
We've been, now we are on cyclic quads. So that means very soon we'll be entering into the world of tangents. And the chord and the tangent and the radius, you see. So we are going through them one by one, piece by piece. We'll get there very soon at the end.
Yes.
Yeah. So yeah, thanks Mfana and Presh. Yeah, you guys you've been glorious. To say in a few words, thank you so much. Really appreciate you. But yeah, I think that's it for today. These game challenge problem, the rest, please guys, screenshot. If you've screenshot before, that's great. You go and do and complete the rest on your own. Thank you. Right, so bye and good night, Presh. And Mfana, thank you so much, guys. I'm gonna let you go.
Before uhambe sense ngicela ukubuza ukuthi ijwayele kuba ngasikhathi sini uqala
9
ngasikhathi
p.m. my leader, 9 p.m. We're doing 9 p.m.
Oh, okay.
Yeah.
Ngiyabonga se.
Sure, Mfana. Okay. Guys, thank you so much. I know there's a lot more people. You see, now I feel bad because there's people that have been here, like waiting. Okay, let me at least give these people a chance. Like, there's 2 people that have been here that have been waiting, like Usne or Lerad. Let me give you guys a chance. Hello, Sne. Hello, Lerad. Tau.
Hi, sir.
How are you doing?
I'm good.
Okay, I'm just feeling a bit guilty because you guys have been here. I've seen you. You were there. You have requested a while back. So I just thought, let me just have mercy, give you a chance to be, give you a chance, and then I have to also now retire for the night. Otherwise, are you gung ho to do one problem and then we can call it a day? Snare, are you good?
Yeah, I'm good.
Yeah, that's beautiful, man. That's beautiful. Hopefully, we're both either in grade 11 or 12, because I don't want people stealing the thunder who are at university. There's university people that have joined here and they're like, yeah, I just wanted to remind myself.
Oh,
Sneh,
yes.
are you that one?
No, I'm not at university yet.
Oh, what grade, buddy?
It's just a gap year.
Oh, you're taking a gap. Oh, okay. So what are you rewriting then? Are you doing a rewrite?
Yes,
In May, June.
in June.
Oh, okay. Epic. All right. Lerato, are we good to go? So let's do ladies first, and then Snare will come around with you, if you don't mind.
Okay, so
We're looking at this one, Snare.
Okay, sir. I think ABCD is a cyclic quad because It four sides are touching the circumference.
Definitely.
I don't know. Yes. Let's see.
Okay, so assist.
Yeah, you can, please. Yeah.
Okay, since APCD is a cyclic quad, we can
Yeah.
say 50 plus x is equals to 180.
50 plus
Plus, yeah,
is equal
plus
to
180.
180.
Yes.
Okay. Okay, so let's do that. 50 plus x is equal to 180.
Hello?
Yeah.
Oh, ik zie netwerk jam gaan.
Oh, yeah. It says network.
Okay, Lerato.
Yeah.
Uyenzile ubhalile mos le sum le
Yeah,
circles.
I did.
Yeah, ngicabanga ukuthi iqhubeke.
Okay. Let me. Cyclic quad, I get it. You said x plus 50. You said x plus 15, eh?
Yeah.
Yeah, it's 180 degrees because of opposite angles of a cyclic quad.
Yes.
And then
Then
like